Exhibit of hydrogen fuel cell technology. We've been here for quite some time waiting for things to happen, and things have been happening. You can tell by the size of this exhibit. Oh, thank you so much. A little bit of hydrogen with oxygen. Things are changing. And one of the issues that we face with hydrogen is it a nasty molecule to deal with? What do we do when we want to use it in transportation? How do you store it best? And pipe it maybe from one country to another, or take it on a ship. There are options here that people don't discuss that often, but they're absolutely necessary because we need an international supply of hydrogen, not simply a local supply of hydrogen. There's a specialist I talked to, and preparing for this conversation was fascinating because I ran into issues that I, myself, in 20 years of doing moderations here, had not heard before. I'll be talking to Ralf Ott. Ralf is the head of regulation and policy at Hydrogenious LOHC Technologies, and we'll be talking about enabling safe and viable hydrogen supply chains with LOHC. So, welcome with me, Ralf.
So, hi, nice to meet you.
Hi, Ralf. So, first things first, tell us about Hydrogenious.
Well, Hydrogenious, first of all, it's dealing with LOHC because it has it in its name. It was founded 10 years ago. It's a university spin-off. Actually, still, the University of Erlangen-Nuremberg has some shares in it, so it's basically a real success story of a startup. Now more than 200 employees, lots of international investors like AP Ventures, Vopak, Temasek, Chevron, Hyundai, Mitsubishi, some of the well-known. And yeah, we develop LOHC, a liquid organic hydrogen carrier, to transport, store hydrogen, and to bring it where it is needed.
We have to talk about energy storage whenever we talk about renewable energies, but let's break this down, starting with the equation of why and how best to store hydrogen. It's produced often by renewable energies. You want to maximize that energy revenue, expand the applications of renewable energy, but you have to do something with this energy. Sometimes we simply have to store it. So what are the options, and why LOHC?
Well, first of all, unfortunately, currently most of the hydrogen is produced via natural gas on a worldwide scale. So this has to change. I think 97%, 99%. Let's talk in 10 years, and I hope it has switched to 99% of renewable hydrogen. Hydrogen is it's peculiar, problematic, but better than electricity to store, as we all know, and therefore hydrogen can be stored in different ways. Pressurized, everybody knows it. Liquefied, cryogenic, that's what the NASA does. Real space rocket science, that's a cool technology. You can also use it as a derivative, like in ammonia, methanol, all cool technologies, and pressurized, also transported in existing natural gas pipelines. And there are new technologies like metal hydrates, and last but not least, the organic hydrogen carriers, or the hydrogen carriers, where you put the molecule and bind it safely, because hydrogen or the derivatives have some issues, safely into a liquid or some solid carrier. And one of the technologies of these upcoming new technologies is liquid organic hydrogen carrier, where you bind it actually to an oil. It sounds quite easy.
It sounds quite easy. First of all, there's a few people in the audience that hear the word organic and tears come to their eyes. They're so happy. So liquid organic, what is the organic substance you use to bind the hydrogen? And is it really something that we should be teary over, so happy because is it environmentally friendly? Is it a renewable resource? Does it exist already? How much of it is available? Give us the whole issue.
Okay, here come the nitty-gritty questions. Okay, very good. So first of all, organic means it's an oil. Currently, it's also an oil which it's called benzyl toluene. So it's actually made of toluene. Toluene is a product which you often have in oil and gas infrastructure, and then you burn it or use it for something. But worldwide scale, you have it a lot, and you have to do something with it. And we said, okay, we produce out of it benzyl toluene. That's not ourselves, but it's a heat transferred oil used for several years already. And it has very good specifics from a reaction side, from a chemical perspective, that we use this oil and bind hydrogen in it. Now, currently, it's still an oil which is from the fossil fuel sector, but we don't burn it. We instead of using the oil, which we all know, oh, we can burn the oil, which is quite cool to warm our houses or to drive our cars with. And in the future, we want to use this oil actually to transport hydrogen, and not once, but several hundred times in a circle. So each time we bind hydrogen to the oil and bring it to where it is actually needed, the hydrogen and the oil, and then the oil goes back to the origin actually. And of course, what we're also looking into is in a research project together with the European Union, how to actually do the oil from natural resources, like from wood and so on. So in the future, to have it really completely fossil fuel. But instead of burning now, today, the oil, we should use it for transporting green hydrogen.
There's questions of scale already here that come to mind for me, and also how this process works. Long time ago, we had people on the stage here demonstrating their metal hydride storage facilities. What do you have? You have a tank, you put hydrogen in it. The metals are strange, porous, whatever metals that absorb the hydrogen. To get the hydrogen out, you heat them up a bit, and out comes the hydrogen. That's not something one can scale up to the level of demand we're talking about when we're addressing issues, we'll come to them, of shipping. So what is the benefit of using LOHC if you're talking about large scale? Mm-hmm.
So first of all, we already have our systems in the field, commercially available. For example, a refueling station, which we supply with our LOHC and then with fuel cell grade hydrogen. Nevertheless, when we talk about cost competitiveness and a hydrogen economy, we have to scale up. Hydrogen makes sense if we have a lot of renewables and we have a lot of electrolyzers, and then we have also a lot of transportation options, technologies to transport the hydrogen to where it is needed. And the costs always go down heavily when looking at the economies of scale, and that means we have to scale up. And that's what we are doing with our partners, with our investors, into going into the big projects. We're coming up with the important projects of common European interest, IPSAI, and also are looking into, for example, the Middle East, where there's a big push towards blue. So the one hydrogen which comes up when storing the carbons under sea, or in the future, and that's what we want to have, of course, is green hydrogen and transport it where it is needed.
For me, the issue really is getting the supply of hydrogen to the applications. It's odd, and it's true that about 1% of the hydrogen currently on retail for the consumers, which is an industrial gas and so on and so forth, just 1% is really renewable energies. But you still have applications that are necessary. They run on hydrogen because hydrogen is clean to use. Isn't there an argument for saying, let's look at the use case? Renewable energies almost have nowhere to go. We're shutting off renewable energies because it's not a storable source of energy if it's electrical energy. The batteries are not large enough to actually contain all the energy that you can produce with renewable energies in Germany, of all things, not to speak of Africa and the deserts they could cover there. So what are the application-based functions, and what are the advantages of decarbonizing those applications?
So when looking at applications, first of all, looking at our technology, we have 3 applications. So first of all, it's the large-scale transport of hydrogen. Mm-hmm. So bringing it from one harbor, for example, or one renewable energy field where hydrogen can be produced, to, for example, the port of Amsterdam, port of Rotterdam, port of Hamburg, and then, for example, inject it to the European hydrogen backbone, where we have, hopefully, in some time, hydrogen pipelines through the whole continent. Nevertheless, this is one application, but in the future, we will not see that all over Europe or all over the world we have pipelines. But we need also other ways to bring the hydrogen to where it is needed. Maybe small industry applications like the gas industry, the glass industry. They need a lot of heat. Currently, they usually use natural gas. In the future, hopefully, they can also use hydrogen and also renewable electricity. So this is also one application for our technology, and also the refueling stations far away from any pipeline system. And last but not least, what we also want to do with our technology is to directly couple it with, for example, ships with a fuel cell, and then have a zero emission system directly coupled with our system, where we have the hydrogen bound in the oil. Then we need to put the oil out, to unload it, some heat. We use the heat from the fuel cell, from the, for example, SOFC, and then can actually propulse or have the engine for the shipping industry, the hard-to-abate sector, the maritime systems, where they are used to using oil, but now we tell them not to burn the oil, but use the oil just as a carrier. And then when you go back to the harbor, you unload your unloaded LOHC, and it's quite a circular economy.
This is all, it's a very humble way of stating the case of your business model, I find, kind of underestimating the massive scale you just referred to. Germany has made the mistake, egregiously, of being dependent on one source of hydrocarbons. To diversify the supply is a big issue. And of course, people do refer to, here's a question in the audience, does anyone know the answer? Is Germany going to be able to produce enough renewable electricity to supply not only the electrical grid, but also to supplant all of the energy consumed in the mobile and industrial applications? Can Germany do that? No. We are going to have to import. Japan knows this. They've known it for quite some time. And a lot of people think, so just drop a pipeline into the water from here to Africa, and it's a recipe for what we've just gone through, which is a lack of diversification. So you made the metaphor here, and I find this really important. You used the metaphor of, we have these ships that transport oil. It'd be nice if they weren't diesel engines propelling the ships. Well, that's something that we can solve. But it's also a potential to use those vessels, these recovering assets that are massive investment, to use those assets to transport green energy from anywhere in the world. It's a supply chain indifference, which is exactly what you need. Is this part of the dream of LOHC?
You're always already telling our success story, so thank you very much. Now, of course, LOHC, when the company was founded, it was exactly the idea, using existing infrastructure, not just the ships, but we have massive investments in the fossil fuel infrastructure at ports, at the storage tanks, massively. And what we have seen from last year, I mean, the energy crisis in Europe or a worldwide scale, what helped us a lot was the resilient and flexible liquid oil infrastructure. It was not the natural gas, naturally, as we have seen that some pipelines can burst. It was not nuclear, unfortunately, as we saw in France, but it was some renewables and a lot of flexible oil infrastructure, which helped us out. As you say, we need a lot of energy. Europe is aware of this. Germany is aware of this. And I think now we should take very serious decisions and diversify our whole supply chain. And as you said, we see it from Asia, we see it from Japan, Singapore, South Korea. They know about it and they diversify heavily. And that's why also I get always the question, which is the technology? Are you better than ammonia to liquefied hydrogen or pipelines? And I say, when looking at the studies, the international ones, yes, we come out very, very cheap, cost competitive to the others. We are more easy to handle than the others. have our also backdoors with regards to our oil, which we have first to produce. But nevertheless, it will be not one silver bullet technology for all the applications which we see, but there will be several technologies which we need, not just because they are more suitable for one use case, but also to diversify our import technologies and our reliance on some technologies, some countries. And I think with the LOHCs, we have a lot of infrastructure in the oil business. Let's just use that for clean business and not for the dirty oil business, which we know.
It's almost giving oil a good name. I don't want to have said that sentence. I'll have to correct it at some point. But you're right about this. One Japanese representative on the stage here shocked us all by saying, he was talking about his wonderful electrolyzers and other products, but we said, okay, so you're going to operate hydrogen vehicles and so on. Where are you going to get the hydrogen from? Is there enough renewable energy? And he said, no, we're going to import it. People are not aware of the fact that this is going to be an import commodity of a scale to be comparable with, hopefully, the oil and gas industry. We still have to talk about the actual process. Whenever you're thinking about applications, and I think, Ralf, you're really careful about this because this is not an argument against using pressurized tanks. This is not an argument against having mobile applications with 300 bar or 700 bar tanks, but we all know that pressurization requires energy. There's always this sort of loss in all of these equations. It's the same thing with batteries. So how does this process actually work? How do you feed the hydrogen in? Is there an energy loss during that process? And also, when you recover the hydrogen out of the oil that you're using, what energy factor plays there?
Yeah. Very good question. First of all, I'm an economist, so I quite often get the question from engineers, what is your efficiency? Efficiency is everything. No, for me as an economist, and in the end for everybody, it's how much does it cost to use, in our case, transport technologies. And so therefore, efficiency is one point, but in the end, it's the cost. When looking at our technology, first of all, we are binding the hydrogen molecule to the liquid. It's a catalyst endothermic reaction. So you have a reactor, you put your hydrogen and your oil together, and you get heat out, actually. So where the energy is, we get heat out, which isn't the best thing, actually. Should be better that we get heat out when we unload the hydrogen from the oil, but I will come to that later. First of all, we are still there. We are binding the hydrogen molecule to the oil, have some excess heat. What we are actually thinking of, also doing some projects, to use this excess heat, for example, for desalination. There are two technologies, and one is needing heat. And then we transport the hydrogen in a ship, train, truck, whatever, from the existing infrastructure, and then unload the hydrogen. And now it's, again, a reactor, but it's exothermic. So we need to put in about 11 kilowatt hours of thermal energy, which is about 33% of the energy which is in the hydrogen molecule. And then we can bring out the hydrogen and then use the oil, bring it back to the origin. Now, two things. First of all, how do we get the thermal energy? We are looking at excess heat. So it's about 250, 300 degrees Celsius. That's heat temperature level, which is feasible, which is there already. But in the future, of course, we are also looking into high temperature heat pumps to get hold of this energy. Or actually, we are combining already on ships our technology with fuel cells in order to get the excess heat from the fuel cell and use it for unloading our hydrogen. And secondly, what we also get quite often asked, yeah, but you have to bring back the oil to the origin. That's so horrible. All the other technologies are better, which is really nonsense. So because with any other technology you have right now, you always have to bring back the truck, the ship, to the destination where you get new oil or whatever energy carrier you have. So only with pipelines it's different. They are there and always there. So this is not an argument against our technology, nor it is a big advantage of our technology. It's just like every other technology. And So if we get efficiency rates, I think we are in the same level as, for example, ammonia. We have some advantages because we need less temperature levels, and maybe you can thus use excess heat, for example, or a fuel cell. But nevertheless, again, what I said already, there is not one single technology for each application. It always depends a little bit. I hope that answered your question a little bit.
It did. And I mean, you know, der Teufel steckt im Detail. The devil is in the details. This is why the conversation can't end. We have to really visit you at your booth, which is C25, to talk about this. It is so vital to get behind the issue of efficiency because it is often an absurdist narrative. For example, if you have an engineer looking at the efficiency of a solar cell and he's saying, oh, it only is 50% efficient because it only translates 50% of the sun's energy into electricity. Does that interest anyone who wants to know what the kilowatt hour price is of electricity? Why would that be of interest? Are these devices, do they finance themselves at some point? These are the big issues. So I love the fact that you're an economist because that helps us deal with this. So I've been talking to Ralf Ott. Please consider continue the conversation at the booth, which is C25. What direction do we have here? C25 is...
It's over there, the nice red one or whatever color it is.
Exactly. Okay, so I've been talking to Ralf Ott. He is head of regulation and policy at Hydrogenious LOHC Technologies, and we've been discussing enabling safe and viable H2 supply chains with LOHC. Thanks all for being here, and I hope to see you next year.
Thank you very much. Thank you.